This is the video for Lesson 6 in Module 1 called Points of Concurrencies. The opening exercise starts off with a construction that we did in the last lesson about making a parallel line to a given line through a certain point, except in this one, we're going to do it a little bit differently. They want us to make it using the technique of copying an angle. So I'm going to take our compass, and we're going to line it up at point B. And you can see already I've drawn in a transversal. What we call a transversal is just another name for a diagonal line through points A and B. And I'm going to make an arc across the angle here with the compass starting at point B. I'm going to move my compass now to point A, making the same arc from point A. You can kind of see it's the same thing from B and what's going to be angle A in a second. The next thing I'm going to do as I change the color is move my compass to the upper intersection point where the first red arc hits the transversal. And then I move my compass to the second point. Make a little arc going there. And the same thing up on the copy, where the copy is going, compass on the red intersection point, and I make my little mark there. That X is where our line is going to go through. So I have a line up here, which I'm just going to drag down in place. So there's our parallel line. Now again, we have the same method that we did in the last lesson where you make two perpendiculars. It's kind of up to you which one you find more beneficial. I'll leave the steps up on the screen for a minute if you want to pause and write down or copy these steps. All right. So today was called Points of Concurrencies, and the first point we're going to look at is the point where perpendicular bisectors meet in a triangle. So if I take my compass and do a perpendicular bisector, I'm going to pick first the left side, and I go a little bit further than halfway along the left side of the triangle, and I make almost a semicircle going up and down. And I do the same thing from the other corner of the left side. Semicircle going up and down. After I have my little shape here, those two arcs that intersect, I'm going to connect them with my little dotted line segment. And I'm going to make it go all the way through the triangle there. I'm going to do those same steps to the other two sides of the triangle here. So I'll do the same thing to the right side. I'm just going to change the color a little bit. So on the right point, I go a little bit past halfway, make an arc from one side to the other. I do the same thing from the other point, the other vertex of the right side. And now if you look, I didn't make that first arc quite big enough. There's a little tiny space where they don't hit. So I'm just going to go back to the right endpoint and fill that in as far as I need to. Connect my 2 points here. And you can see where these two perpendicular bisectors meet. If I quickly do that third one, they're all going to intersect at the same point, and we will give that point a name in a minute. So big half circle on the bottom coming from the right side. Same exact half or semicircle coming from the left side. And where those two guys cross, we see that point right in the middle there, this what's going to be a bright purple point. That point is called the circumcenter. Now, technically, anytime three lines intersect at a point, we call those things concurrent. If two lines intersect, we call that an intersection. But if three lines hit, we call that concurrent. The point is just called the point of concurrency. But like I said to start this one, specifically when three perpendicular bisectors intersect, that specific point has a name called the circumcenter. And that's that point in purple right in the middle. Every triangle will have a circumcenter. Depending on the type of triangle it is, if I scroll down to the bottom two examples here, in a right triangle, like we see on the left side here, if I quickly just sketched in the perpendicular bisector for all three sides. On a right triangle, it's always going to end up being on our hypotenuse. That's just kind of how it works. If I draw in all three perpendicular bisectors for an obtuse triangle, which just means one angle is greater than 90, it always happens to happen outside of the triangle, like we see in the example on the right side here. But we still call it a circumcenter no matter where that point happens to fall when perpendicular bisectors meet. On the next page, kind of a little question to follow up about circumcenters. Just picture, all they're telling us is what we see highlighted here. Point P is the circumcenter. That tells us a couple of things. First, these blue dotted lines, I'm going to make them a little bit longer. They are the perpendicular bisectors. And the thing that happens to happen in these triangles is, in our perpendicular bisector right here, because it's a perpendicular bisector, those two sides are equal, and the line is perpendicular to that side of the triangle. Same thing on this side here. Our perpendicular bisector coming out of the circumcenter bisects the left side, also creates right angles. And it's going to be hard to draw in because there's a lot of stuff going on the bottom side here, but in this perpendicular bisector, the bottom got bisected, and again, also we have a right angle there. All right, so that's always going to happen when we see the word circumcenter. We know we have perpendicular bisectors in our picture. On the next page, we're getting into the second point of concurrency that has to do or come from angle bisectors. So I'm going to take my compass, and I'm going to do the construction for an angle bisector where I make any mark I want that goes across both legs of the triangle. I'm going to move my compass to one of those two intersection points and make a little mark through the center of the angle. Same thing from the second intersection point. And again, once we have that X, there is angle bisector, draw it all the way through, angle bisector number 1. I'm going to do the same thing through the other two angles of the triangle, so I'll go up to the top angle. Same thing, a little arc that hits both sides. I'm going to go to one intersection point where the side's hitting that blue arc. And I'm going to get another X in the middle of the page. These two red arcs have to be the same measurement. And then we have angle bisector number 2. Now technically the point where they're both meeting already is that point of concurrency. I am going to draw the third one in just so we can see that all three will still hit at the same point. So there is my arc on the right side angle. I make another little mark on the inside in red. And I go to the other green intersection, make another arc in red. So we get our third angle bisector. So this point where they are all meeting, I will make the point in yellow here. That point is called the incenter. So the same way we have a specific vocab word, when perpendicular bisectors meet, we get a circumcenter. When the angle bisectors all meet and intersect, we get an incenter. And that's the vocab word underneath this box here, incenter. The reason why it's called the incenter, unlike the circumcenter, which could be inside or outside of the triangle, incenter is always going to be inside. If I go down to the two other types of triangles, the right triangle and the obtuse one, if I roughly draw in two angle bisectors, I'll actually draw in all three, we see the two incenters are always going to be inside those triangles, no matter what. So they're incenter number 2. And that is the end of lesson number